Hello squads, today we're going to talk about linear functions. It's probably the first function that you're going to learn. So linear comes from lines, so our graphs are going to be linear. So the first part about linear functions we're going to talk about is slope. So today's lesson is designed all about slope. So what is slope? Well, where do you hear the word slope? The best case would probably be going up to the mountains, right? Going down the slopes, going down the mountain slopes, black diamond or just the bunny slopes, right? So, but what does slope mean then? Slope actually means steepness. In other words, slope describes how steep a line is going to be. So if the slope, as we're gonna refer to as m a lot, the number as m gets greater, our slope actually increases. So as m increases, our steepness increases. Our steepness gets more steep. So think of like a black diamond for those who snowboard. A black diamond would be a very high slope. All right. If the slope is closer to 0, so m is closer to 0, right? Our steepness actually gets less steep. So it gets less steep. So just to check your knowledge, check for understanding, well, what is if my slope is 0, what does that mean? If my steepness is 0, what does that mean? Good. When the slope is 0, that just means it's flat. There's no steepness, so no steepness. So it's like flat. So like the ground in my classroom is a 0 slope because it's flat. Right? A bunny slope is very close to 0 as a slope, almost close to 0, depending on where you go. But that's how we talk about slope. That's the definition of a slope. All right, next part when we talk about slope is it linear or not? How do we identify if a function, how do you know? How to identify if a graph or some function is linear. Right? When we talk about linear, we should talk about slope. What does slope also represent? Slope also represents constant rate of change. Keyword is constant. When we talk about line, if something is a straight line of an increase, then it should be constant. So every step I take, let's say I take 1 step per minute or 1 step per second, that's linear because every second that goes by, I'm taking 1 extra step. So it's constant rate. It's constantly changing, but it's at the same rate though. That's the most important part. So for 1 step equals 1 second, so then what would 2 seconds be then? It'd be 2 steps. And what's 3 seconds then? It would be 3 steps. Right? What do you notice? Well, so every second that goes on, you take 1 step. Well, do you see a pattern? Yeah, we're going up by 1. How about here? What's our pattern here? We're going up by 1. So our slope, how do you find slope? Slope is going to be the change in your y's over your change in your x's. We're going to go more in detail than that. Today we're just focusing on, is it linear or not? Well, as long as there's a pattern with addition or subtraction, and it's a constant rate of change, then it will be linear. Let's take our first example. Let's say I have a table couple points. Is this function linear, or is this some other type of function that we haven't talked about yet? Well, the way you do that is figure out, well, is there a constant rate of change? Can we see if there's any patterns? Well, here, what are we going up by? We're going up by 1. Here, what's happening? We're going up by 1 as well. Because there's a pattern there and a pattern there, it could be separate. This is, yes, it is a linear function. All right, let's try our next example. Let's find the slope. Let's say I give you another table. 2, 0, -2, 0, 2, 1, 2, 3. Right? First part, is it linear? Well, it's going up by 2's here. It's going up by 1's here. Well, how do you find the slope? Well, it's your rise over run, or it's your changes in your y's over your changes in your x's. So doing this difference is actually giving us our answers there. So my slope is actually going to be 1/2. So every 1 it rises, it's going to go over twice. Think of it that way. So every 1 it rises is going to go over 2 spaces. So every step I take, it takes 2 seconds. You could think of it that way. And our last example, find the slope graphically. So if I give you a graph, let's have a couple points. So 0, so you have 0, 0, and then 3, 1, and make this graph like this. Is this finding the slope with this? One obviously is linear, but what is the slope? We can use rise over run. So you start at one point, and you're trying to get to the other point, but how would you get there? You would rise how much, and you would run how much. So I'll rise up 1, go over 3, so my slope is 1 over 3. So that's my slope. Is this slope pretty steep or is it pretty flat? It's actually pretty flat because we're getting closer and closer to 0. All right, so that concludes our lesson. Let's try our 3 examples. Practice problems, your beginner, intermediate, and advanced level. Good job. All right, your beginner level problem. Let's try this. Look at your notes if you have to. Let's say I have a table. And ask you, is this linear or not? That's the question. Linear? Is this linear? About 30 seconds to a minute. Try it. Look for patterns. Look at your notes. Just try your best. Go. All right. What was your answer? And hopefully you have a y. Linear and then y. Well, what's my pattern? You're going up 1 here. What's my pattern here? You're going up 2 here. So it's a constant rate of 2. So every 1 I go, we're going by 2. So it's 2 over 1 is my slope. So because it's a pattern, it is actually going to be linear. All right, check your answers. Make sure you did it correctly. Not just yes and y, but explain the why. Okay, let's find the slope now. We just did that other problem, but I didn't ask you to do that. So let's say give you another problem. 1, 3, 5, and then 2, 4, 6. It is linear, but I want you to figure out what is my slope. What is m? All right, about 30 seconds to a minute. Check your notes. Go. So what is my slope? Well, let's find out what the equation is. y2 minus y1 over x2 minus x1. Try to always remember this. It's a very important formula. Just really try to conceptually understand that rise over run. Rise going up and down is my y values. Run left and right represents your x values always on a graph. So a couple ways of doing this. You can figure out how much is going up by, and then divide my y's over my x's, which is 1. Or you can just create points. So you can say it's like 1, 2, and then 3, 4. Any points you want, and then use the formula. So 4 minus 2, y2 minus y1 over x2 minus x1. So you get 2 over 2, which is 1. Either way, you will get the answer. All right, so check your answers once again. Let's try our last problem, our advanced problem. Let's say I give you a graph, and then it's linear, and I want you to find what the slope is. So either use rise over run, or use the points given, so 1, 0, 0, 2, and then find me what the slope is graphically. I'm going to give about 30 seconds to a minute. Try your best. It's your last one. Go. All right, let's see if you got this. So I have 2 points, 0, 2, 1, 0. I'll do it both ways. The easiest way is just doing rise over run. How much am I rising to? How much am I running? -1. So then, what's my slope? Rise over run, so 2 over -1, which is -2. Or you could do it through point 0, minus 2, 1, minus 0. y2 minus y1, x2 minus x1. So you have -2 over 1, which is -2. One important topic as well, when we're talking about graphs, if it's looking like this, like a decrease, going down the mountain, that's always going to have a negative slope. And if you're going up the mountain like this, it's always going to be a positive slope. But we'll talk about that more. So that concludes our lesson with linear functions. Hopefully you understand how to find slope and how to tell if a function is linear. Hopefully this video has helped you. Please subscribe to my channel. Please turn on your notifications, and let's get ready for some more math videos.